Hello students, welcome back to Embedded Pathshala. In the previous lectures, I have shown you what are pipes and FIFOs, inter-process communication techniques, right? So in this video, we will see one more lecture on inter-process communication techniques, which is message queues. Okay, so what we have seen, the previous communication techniques like pipes and FIFOs are basically byte-oriented and message-oriented. Right. So FIFOs are basically message oriented techniques, unlike message queues are basically message oriented techniques instead of pipes and FIFOs, which are byte oriented communication. We will see what is this message oriented communication. Okay. Just understand this is not like simple byte based communication, it is based on messages. Now, what will happen is here there are two components, one is reader and one is writer. Writer will write the message into the queue and reader will read the message from the queue. Okay, so in POSIX, in message queues, we have option called priority. So queues permit basically each message can be assigned with some certain priority, and based on that priority, message queues can be handled. Okay, so what will happen when priority is assigned for a message? High priority message will be queued ahead and low priority messages are handled later on after high priority messages got completed. Okay, like how FIFOs are present in the file system, similarly, message queues are also present in the file system under dev and MQU. Okay, this is one file system where we will be creating. How FIFOs got created in temp, similarly, message queues will be created in this particular directory. Okay, now we will go to next slides. So concept is message queues are basically message oriented instead of byte oriented. Now, how in system calls we have open, read, write, and exec mode we have exec ve, execl, these system calls. Similarly, for message queues, we have system calls like enqueue open, enqueue close, unlink, send, receive, set attributes, get attributes, these kind of things. Okay, let's see one by one what are these system calls means. First, enqueue open. What enqueue open does? It creates a message queue and it helps basically in writing. Basically, it will create one message queue and return the queue descriptor. How open will open the file and return the file descriptor. Similarly, enqueue open will open the message queue or create a new message queue and return the file descriptor of the open message queue, just like open system call. Sorry. Now, MQ send. This function will write the messages onto the queue. MQ receive will read the messages from the queue. MQ close will close that message queue process which is previously opened by open, MQ open. MQ open to open the system, I mean message queue or close the message queue. MQ close is to close the message queue. This is the difference. Next, unlink means basically we will tell that after deleting, after queue deletion, after the process has been closed, you can delete that particular message queue. For that we will be using MQ unlink. So these are the main system calls that we will be using in message queues. Okay, now this is the syntax of how we will open the message queue using MQ open, but better I will show you in code while writing so you can understand. In case if you are taking notes, just write the syntax and leave, we will see in the code. Okay. Important point is here MQ my queues or message queues basically should always start with this slash character. Only after this you need to create your queue name. So this you should remember. Now MQ open, similar to open system call. It will tell whether you want to open the message queue in read only, write only, read write. If not there, you can create, exclude or non-blocking. These options you can give in the message queue. Okay. Next. Oh, create, you know, right? For read, write these things. If message queue is not there, you can create a new message queue and a flag parameter for what kind of mode you want to open, just like open system call. In the very first lecture, we have discussed. Next, attributes of the message queue. Message queue will have some attributes. Basically, they are all stored in the structure. For now, we will understand what are the attributes of the message queue. They are max messages, maximum number of messages in the queue, and maximum size of each message. Next, number of messages that are currently in the queue. These parameters will define the message parameters. Basically, these are the parameters for message queues that we need to understand. I mean, attributes of creating a message queue. When you are creating message queue, you should consider all these attributes. Now, similarly, send and receive. Message queue send is to post the message, and message queue receive is to receive the message. We will write the code and see, but API's meaning is to send the message and receive the message. And how for p threads we are using -lp thread. Similarly, for message queues, you will use flag which is -lrt. This will link all the message queue related APIs or libraries. Okay, so next important thing you need to remember is whenever message queue is success, it will return number of bytes received in the message. If it is a failure, it will return the -1. This you should understand. Okay. Now, always remember message queue name should be passed as an argument in the command line. We have seen how we will pass the command line arguments, right? So similarly, we should pass the name of the message queue in the command line argument. This is one more important concept. Now we will compile the code and we will see how things will be working in message queues. Yeah. So let's start writing message queues code. Okay. Now, what is the first thing? We should send, right? mq send.c. Right. Stack.h code. Now, now, first we should define a queue. Let's go to and queue. Done. This is what we discussed. There will be one struct which is called as mq attributes, and we are creating a variable for that attributes. Okay, done. And we also discussed we need some message length. Done. Till here you are clear, right? Now what we can do, if see, always remember how this message queue we will work. It's not like a simple gcc-o. I will tell you. First, while compiling, you should tell like gcc-o executable name, then -lrt source file. Okay, now executable has created. Now, how to use message queues is executable name and message queue name. You should give this during runtime. Any name during run. Next, message you want to send. Okay, this is the concept. So in command line arguments, this it works. Or okay, let me write message queue name should always be given due okay from command line. So how many arguments we will expect? 1, 2, and 3. If it is less than 3, that means user is not understanding how to send the command line arguments. So we will print an error message. Okay, if argc is less than 3, that means invalid, right? So you should tell like fprintf std error, and syntax is executable and message queue name and message. Now user will understand, okay, I should send the arguments in this format. Okay, now q equal to mq open, because return type of mq open is mqd underscore t, it will return, right? So that's the reason we are creating mq open, just like open system call basically. Now mq open, what we'll do first, argv of 1, this is where message queue name is there, so we are opening that message queue. Okay, now parameters, I want this to open in right only. If it is not there, you create, and I am telling the permissions and the parameters arguments. I don't want anything for now, so it is null. Done. If q equal to mqd underscore t of -1 means message queue open error, it will print, and it message queue get attributes. What will do? It will get the attributes related to that particular message queue. It's equal to -1. That means error mq get attributes mq close and q. We are close. If it is error means. Okay, then and if it is not a failure, then we will print the attributes. Right. Attributes values you can take. Now printf slash n mq max message equal to percentile d. This is one of the attribute. Again, mq message size equal to percentile d. This is another attribute in the structure. How we can print them? Typecast. We should typecast into integer. Okay. X dot mq max message comma int at MQ message size. Done. We will print the message attributes, basically attributes of this message queue, which are defined in the structure we have seen in the presentation. Okay. Now message length equal to strlen argv of 2. So what it means, argv of 2 means argv of 2 will be this one, 0, 1 and 2, the message you are sending. So that length you are getting in the message length. Okay. Now if we don't know how much will be message length, right? If it is greater than attributes dot mq message size, means if we are trying to send something that is greater than what is expected, then what I will do, well, we should always ensure message stays in the limit. Okay. Message is too long. Done. Too long, and we are closing the message queue. Done. Wait. If mq send q comma argv of length of argv of 0 is 1. So what we are doing, it is like MQ send. MQ send is to post the message. Where Q, what is this Q? The Q is the file descriptor of the message queue that is opened using MQ open. Basically, there how we will use file descriptor FD. This is also file descriptor of the message queue that is open. Next, argv of 2. What is argv of 2? The message. Next, length, right? Length is str length of this one. And last as the parameters, that let it be 0, which is not required for now. Done. Basically, I mean to say is we discussed about message queues support priority, right? The one is, it is one of the attributes in the message queue. For now, I don't want any attribute or any priority for this particular message, so let it be 0 or no need of now. Okay. Now p error and mq send. If it is a failure, means we are not able to send data into message queue. Now mq underscore close queue and return 1. Done. So let's I mean give you an overview about this one. First, message queue concept is you should send you should give message queue name and the message you want to send. Basically, it is message based. Okay. And compilation, you need to add this LRT flag for message queues to compile. So compilation and execution part, you are clear. Message queue name always should be given from the command line and message also should be passed from the command line. This part also clear. Leave. Now, here we have added an error check in case if the parameters are less, we are telling user like this is the syntax you need to follow. Okay, clear. Now, if everything is fine, we will open the message queue. In message queue, open means remember the open system call. First is the path to the file name. Here argv of 1 is the message queue, right? That is the file name we are giving. And we want to open it in write only mode. In case if it is not available, you create that message queue. with permissions this one and parameters let it be null, which is not needed as of now. Now, then if it is success, file descriptor will be 1. Just remember open system call. In case if it is a failure, then we are telling a message queue open is failure and returning. So assume this passed. Done. Good. Now, after queue is created, we need to know the attributes of the queue, like what is the message size, maximum number of messages supported, this information, right? So there are multiple attributes, but we are considering these two parameters. Now we are getting those attributes. Okay. If it is success, then I am printing what is the maximum number of messages supported and maximum message size of each message. That information I am printing. Now, message length, what is second parameter? Their information, basically I am getting the information from str length. Arg of 2 means message. That information I am getting. That I am assigning to the message length. Now, in case if the message length is greater than the maximum message size supported, we are throwing the error. If it is less than the maximum message size supported, then I am sending the message to the queue. I mean, from the queue, the message is argv of 2 and how much size is str length of argv of 2. Done. After sending, you will close the message queue and return. This is the code from the message queue sending end. Okay. Now we will see message queue receive dot c. I will explain what are these things because you are not understand at this point. Wait, let me come. Or we will start with you only better. Okay, first I am declaring a queue because queue will return what it has file descriptor of the open queue. Okay. Similarly, here also there will be a syntax how we used for sending the message. Here it will be executable name and message queue name. Like this, you should run. So if argc is less than 2, printer the error send executable and message queue. But now queue, it's like file descriptor. Okay, equal to mq open means it will open. What it will open? what it received as the first argument. First argument means message queue name. That we should open here in read only mode. In case if it is not there, you should create. And it's only read operation, right? Better, let's give right. Let it now you opening that. If you want, you can write error check, or for now, I'll just ignore the error check. That is also fine. No need to worry about the error check because okay. Next, MQ get. So I'm getting the attributes of message queue. Okay, queue and yes. This we should declare above. That is why I did not write earlier. So here you can write as struct MQ attributes is attributes. Okay, now after some message pointer I want. Next, received data, some variable. Don't worry, I will get to know why I'm using. Next, receive the information. So previously in the previous code, you are using MQ send to send the data. Now it should receive the data, right? From where it should receive the data? The queue we have created. And next parameter is message pointer. Okay. Dot queue size. Here, number of messages not needed because we are not sending any messages. We are just receiving the message. Okay. This updated. So get attributes. After getting attributes are equal to, we should allocate some memory for this messages. How much memory you want? See, every based on the attributes we will have message size, right? So what is the size of memory we should get, and that much memory you need to allocate for this pointer. So what will happen once you received I mean once the sender sends the message, you will receive the message. In that message you can use that pointer because you will be having the memory to store the received messages. Okay, means on this particular queue, on this open file descriptor, if you have any data that will be, stored into this MQPTR. So this is just like read and write system calls, how they are working, just similar to that read and write system calls. Yes. Yes. First, we are writing data into MPTR. How much data? Size of message. And that we are printing, that we have received from sender. Okay. Yeah. So let's compile the code. Now BCC -o MQ send -LRT MQ send.c. Now GCC -o MQ receive -LRT MQ receive.c. Okay, MQ.h not there on. Type put spelling mistake. MQUU. Again type ATTR. Done. So till now we have compiled the code. Now we will see how we can run this code. Okay. Here also let me come to that thing. See message queues ls. Okay. Let me clear it. Here send. How we will send? First MQ send message queue name. What we will keep? MQ. Okay. Any name you can give. I'll keep as message queue. And the message. Hello. Hello. Now ls dot slash MQ receive where MQU hello. So here I have sent you message sent and message queue name and hello. Same message I was able to receive here. Hello. If you see again, MQ sent, this is message queue example. And this, okay, space, it is not constrained. So whatever you are typing over here, that is getting reflected there. Or if you want to try message send new queue, hello, new queue. Here, new queue. See, this is how message queues work based on the message parameters. Here you can see maximum messages supported 10 and the length supported 8912 and priorities, these things will be there. For now, you just understand how message queues works. This is how message queues basically work. Now I want to show you one more example. So always. Yeah. So what we saw in FIFOs, it got stored in the temp directory, right? Similarly, for message queues, cd/dev mque ls c new MQ, new queue. These are the queues, message queues that we have created, and they are stored in this particular message queues. This is the directory where message queues will be stored. So if they ask you where message queues will be stored, you should tell like message queues will be stored in dev underscore message queue. Okay. Now let me show you one thing. ps-ef grep mq. Yeah, process complete. No worries. Yeah. So basically, this is how MQ, I mean, message queues will be working on. Okay. Okay. Let it be. So this is the concept of message queue, students. So now you know what are pipes, what is FIFO, and what are message queues, right? So this is a major concept in the inter-process communication. We have two more things, which is called as semaphores and shared memory, that we will discuss in the next lecture. For now, this is what I want to teach you. Okay, sure. Thank you.